Hello guys. It's been a few days. Trying to rearrange a little bit. Shuffle things around. I don't know what I meant by that. Just recenter everything. All right. Nice. We're gonna do a Leetcode problem after I do a monkey type. Now, today might be a little more aimless than most because besides doing scheduler development, there are some other tasks that I'm still uncertain which to do yet. So something I could think about right now, but I think it's better if I just do a Leetcode problem now. I already went to the gym. I already did most of my health related activities. Now it's just time to hone in and do some Leetcode. Dude Pro X, hello man. First to chat, first to join. I'm thinking of making like some actual YouTube videos discussing about certain topics, ideas. Except I don't know exactly what I should start talking about. Okay. Hello Nuffy. Dude Pro X, you have an OA for Amazon soon. If you did it, was it similar to Leetcode? Yes. Yes. It was similar to Leetcode. I mean, I got a heap problem or a priority queue problem and an array problem, if that's any help. The array problem was the harder one though. The heap problem, I solved it all. Generally, I find the heap problems easier. Nuffy, got my dactyl keyboard today, nice. It's a learning curve to get used to, especially with blank keycaps. Oh, I wouldn't go to straight blank keycaps straight away, man. That's definitely. I kept the colored keys on before going into blank keycaps. Yeah. God damn it. B C dash A K L stack let's see. dash. Wait, I need to know backspace. So on the lower layer, so no, this is the symbol layer. Backspace with, I see. How will I do a comma though? It's the top corner here. Interesting, okay. So this. I clicked the wrong button. I gotta just practice symbol layer keys. Percent to range 10. Backspace. Backspace. Okay, 0. Okay, now the number layer space symbol. That would be good to know. Number layer space symbol. Ah. Okay. Nope, that's not it. Wait. Ooh. Wait. GG easy. On the call Mac layout. Caller Mac layout. Yeah, I still gonna have to learn about that. I don't know if I can even learn it over the holidays because of the internship. I should, right? I should, ideally. Okay, space symbol from the number layer. Space symbol from the number layer. So the number layer, space. Okay. Why is that underscore when it's also tab? Okay, doesn't matter. 2, 4, 6, backspace. Okay, how do I backspace this in the number layer? Ooh. In the number layer, that's kind of not intuitive. It's all right. 6, 8. If predicate is none, predicate bool for x in iterable. If not predicate x, yield x. Def solve sudoku I is equal to 0, j. I feel like you should have an equal symbol in the number layer as well, right? Yes. Yes. So maybe I can use that. If I is equal to -1, so negative, okay. All right. That isn't it. It's not this either. -1. Ooh, just the number layer. Imagine just using the number layer. Okay. Return true for e in range of 1, comma, backspace, comma. This is for the number layer. Ooh. I didn't think about that. Space. Whoops. Space. 1 0. If is valid sudo q I j e sudo q I j e if solve sudo q sudoku I j return true sudo q I j is 0, return false. Prosanjit, suggest me some good calculus resource. The only one that I've used is what's it called? I think it's called Calculus Early Transcendentals. It's just this. Take it or leave it. Pking from an empty stack. Return self head next. Doesn't matter. Def repeat object times equal none. Hash repeat 1 0 3 backspace 3 backspace 3 backspace. Where's my 3? There he is. One 0 space 0 space 1 0 backspace. Okay, enter. What's the enter on the number layer? It doesn't matter. Oh, I guess it's 1. Okay. If times is none while true, yield object, else for I in range times yield object. Netcat. Hey man, finally got a job after 4 months of post-grad search. Making out the suburbs with this one. Let's go! Not bad, not bad. 4 months in as well. I'd call that pretty good. That's pretty good. 4 months in, you know? Are you a shift or caps lock user? Depends, obviously. I shift until I need to caps lock. So if you got a string of capital letters, then we're using caps lock. Also, what job are you at now? Is it one that we may know? Okay. All right. Leetcode. Let's go. Yay, so happy to see all of this is done now. Except now we're gonna continue with 1D programming. Should I? Because there would be some leftover graph problems that I could be doing. Make myself more proficient at graphs. But I feel like dynamic programming is probably more useful at the moment. All right, let's do dynamic programming. Longest palindromic substring. It's a startup as a founding engineer. All right, heavy on equity for now, but it's promising and we are expected to receive findings from VC fundings, I see. Yeah, all right. Best of luck with that. I hope things go well, turn out well. Fingers crossed. Best of luck. Because I also was a founding engineer as well at one point of a startup as well. Yeah, we'll see how yours goes. For me, I mean, look at me now. Where am I? But yeah, hope it goes well. All right, longest palindromic substring. Given a string S, return the longest substring of S that is a palindrome. A palindrome is a string that reads the same forward and backward. If there are multiple palindromic strings that have the same length, return any one of them. Both A and B are valid answers, and you just return you return B and B. Whereas you can go BB. All right. All right. Well, how do you do this in a dynamic programming way? What, you look at every substring, store the combination somehow. I don't understand how you could do this. I'm not seeing the solution. From my understanding of dynamic programming, you probably need like an array representation of a certain number of states. Now the states here seem not that good. Maybe the state is, you know, a left and right pointer. Maybe. In your penthouse, of course. Yeah, right. Yeah, well, I mean, you can't really see it. Can't really see it. A, B, A, B, A, B, A, B, D. Okay. Problem is, if maybe you do define it as left and right pointer, but then that's maybe too unique. Because how can you ever? Maybe you need a dynamic programming, a memoized palindromes. Maybe you need memoized palindromes. Maybe. Or you memorize each point in the array. Maybe when you're at A, you realize, okay, largest palindrome there is 1. Could it be palindrome for B? No, it's not A. So B is going to be 1. What about A? BA. That is going to be, because the previous 2 was is the same number, or is the same letter. You know this is going to consist of 3 at that point. And the fourth, well, look at the previous, that was a 3. Look at the one before that, that was a 1. So 3 and a 1. Means maybe it's like 3 minus 1 equals 2 plus 1 is 3. Maybe. But that would mean that's a 3. And you just say keep track of the largest 1. And then D, well, oh, how would you do this? Okay, so here's what I'm thinking, right? Let's try and brute force this, okay? My brute force approach is you're given A, B, D. So let me write A, B, D. At each point, so say this is your left and right pointer. I'm just going to say the right pointer. I'm going to say actually the left pointer over, is on top of the right pointer, so you can't see it beyond the left pointer there. But then the right pointer increments, maybe, to B. What does that mean? Maybe A, B. Why does it increment in the first place? So if it's both at one position, A and B, so A is a palindrome of itself. So you would return the length of, you would return right minus left plus 1. You increment right. I'm going to say that is equal to some maybe memo of position I. Should I do position I or maybe R? It's perhaps R. And then if you're at B, your right pointer is at B. This right pointer increments regardless. You notice that A and B are different. So the front and the back are different. If they're different or the same, you will need to consider it. If they're different, then it's not a palindrome, and perhaps it's removed from consideration. So you don't add to the memo if SL equals SR, that's when you would add to the memo. And Otherwise, you wouldn't add anything to the memo, right? It's removed from consideration. You increment R again. So if it's that, then you increment R. But if it isn't, you'd increment R anyway. And now the question is L and R the same? If it is, then your memo is going to be incremented to 3. And then you increment the right pointer, maybe again. VB, use sliding window approach. That's what I'm thinking, right? That's what I'm thinking. Just trying to think of the condition where we increment L. So, you know, you increment R here again. So it's at B now. And, you know, A and B aren't the same. So you increment L. Maybe like I do a while L does not equal SR. L plus equals 1. So that means this L gets incremented. And then, you know, at this position, you're going to have a 3. And then you increment R again. See that D isn't equal. To B. So, whoops. Space. How do I just space? Forgetting things. Okay. It's not L. Until it becomes L here. And then when it does become L there, the best you can do is 1. So R equals to 1. I don't see then what the point of the memoization here is. If you can just keep a max. Oh, okay, unless you keep a memo of not this, but the range. So max len is r minus l plus 1 of max len. If r minus l plus 1 is equal to max len, is greater than or equal to max len, I don't see how you would use anything else but sliding window. I still don't see how you would use anything else but sliding window. Because L to R plus 1 memo R. Like, I don't see the point of memo R. So while R is less than len of S, return res. Res is originally equal to an empty string. I don't know, let's see. Oh yeah, whoops, I haven't even specified the correct values. Max len is not defined, fair enough, max len. Max len is 0. Okay. Think about it. Gotta think about it. Print L and R. John Doe, what does scheduler schedule? I'm thinking it schedules tasks. So, you know, your tasks that you do, the tasks that you want to get done in a day, those types of tasks. It's literally a to-do list app. L to R plus 1. Oop. Why is it just D as the outputs? So it's not equal to R. You're taking DSA next semester. Is Leetcode good practice while I'm taking it? Yes, definitely, 100%. I regret not doing more Leetcode while learning DSA. So, you know, I would have had more reaped rewards if I did that. So, got to do that. My problem here is now 0, 0 is A, 0, 1 is AB. Now we go to 1, 2. Why is that? Let me think. Okay, yeah, when you increment the L, problem is B and A weren't equal either. So this isn't what I need to do here. So if I check my ABABD approach, L and R, when R is there, this gets... Wait, let me think. Is this even possible? R is here. They differ, so you increment L. And then you increment R. Increment again. No. Because L and R still don't equal, L becomes overwrites R again. So that's not the way what I did there. So to be honest, it should be going like this, and then like that. And then like that. And then maybe like that. Okay, well, yep, I'm at a loss. All right, we'll have a look. Okay, but VB, for this problem, for each character, write a function to check for palindrome possible for both left and right directions. Okay. Check for both even and odd length palindromes. And check which is greater length. Okay, let me think then, if that's the hint you're giving me. Basically the full solution. If it's if you're checking the left and right sides, non-including the center, or including the center. I mean, if you don't include it, say you start from A, BABD, no. From B, you have yes, 1. ABD, no. From middle, you have AB, no. B, sorry. From the middle, BD, no. And then from B, AB, A, yes. And D, no. And then from D, AB, AB. Not including D. But then how would you ever get a BAB? Yeah, nah. Alright, well, let's have a look at the solution. I had a good attempt. Don't want to take too long. So it is 2 pointers. Something about palindromes. What? So why? So this doesn't use any sort of. Okay, wait, no, it does. Okay, that's brute force. Dynamic programming here, and this is 2 pointers approach. Manacher's algorithm. Lots of ways.
Hey everyone, let's solve another classic Leetcode problem today, longest palindromic substring. So we're given a string, in this case BABAD, and we want to return the longest palindromic substring that exists inside of here. In this case, there's actually two, BAB as well as ABA. So we could return either of these and that would be perfectly fine. Now, what actually is a palindromic substring in the first place? Basically, it means that, you take BAB, if we wrote that in the reverse order, which would be, BAB, it's the exact same string. So, like I usually do, let's say you just don't know how to solve the problem. Well, what's the most brute force way you could do it? Well, you could say, I'm just going to check every single substring in this original string and check if it's a palindrome and get the longest one. Starting at B, so I would check this, I could check this, I could check this, this, and this, right? So every substring containing this original B. And I want to check for each of these, is it a palindrome or not? And I would repeat that process with every character, right? So for this A, I'd get every substring and basically keep doing that. Now, the question is, for a string, for example, BAB, what's the time complexity to even check if it's a palindrome? Well, we'd have to scan through the entire string, right? So for any given substring, to check if it's a palindrome, it's going to take linear time complexity. So let's say n, right? Now, how many substrings do we actually have to check? N squared, because we're checking every single substring containing every single character. So to check if a string is a palindrome, we have to do a linear scan, and we have to do that for every single substring. So then that's going to mean that the overall time complexity of this brute force approach is going to be big O n cubed. So the question is, how can we do better? Well, it actually involves understanding how to actually check if a substring is a palindrome or not. For, again, let's look at BAB. We can check if it's a palindrome.
Okay. Brute force will take this much.
By starting at the outside and comparing these characters, and as long as they're equal, we'll keep going until we get to the middle, and then we'll check. Then we'll know, okay, it's a palindrome. But we could also do it another way. We could start at the middle and then expand outwards and check if it's a palindrome that way. So, which one of these is going to help us more? Well, let's think about this. Let's say I wanted to know, for this B, what's the longest palindrome where this B is the center of the palindrome? Well, there's no character to the left of it, so it's just going to be this character, this B itself, right? So it's just 1. What about this A? Well, let's start expanding. There is a character to the left and there is a character to the right, and they happen to be equal. So the longest palindrome with this A at the center is going to be length 3, and it's going to be BAB. Notice how if we do it this way, for each character, we're going to consider it the center, and we're going to keep expanding outwards. We're going to take each character, so that's going to be n, and to expand outwards for each character, it's going to be n again. So for this way, the overall time complexity is going to be O of n squared. So that's kind of clever, right? Like a subtle difference of how we check if it's a palindrome can really improve the time complexity. But hold on, there's one edge case that we're missing. When we take one character and expand outwards from it, like for this B, we're getting palindromes that are of odd lengths. They've conveniently shown us this example where the longest palindrome is actually even. So how are we going to check even palindromes? Well, that's just a slight edge case that we can easily add to our solution. So we just have to remember to handle this edge case when we're implementing our code. Okay, so let's get to everybody's favorite part, the code. So I'm gonna initialize the result as...
So here's ways to go from the middle and expand outwards. Okay, and you check. Would I look at the... Yeah, no, I have to look at the solutions here.
As an empty string, because, that's just a good default case. We'll get the longest length initially set to 0. Now we're gonna go through every single character, or rather every single position in this string, considering it to be the center. So first, let's check odd length palindromes. So I'm going to have a left and right pointer. These left and right pointers are going to be initialized to I, which is our center position right now.
Sure.
While my left and right pointers are inbound, as well as while this is a palindrome, so I want to check that the left and right are equal to each other. Remember, we're starting in the middle and expanding outwards.
Sure.
So while this is the case, we know it's a palindrome, so we can potentially update our result. So we'll check that the length of this palindrome, which we can compute by saying right minus left plus 1, is greater than our current result length. Then we update the result.
Yep.
And we also have to not forget to update the result length. I usually forget to do this. And let's also not forget to expand our pointers outward. So our left pointer will be shifted to the left. Our right pointer will be shifted to the right.
Sure.
So now let's
Sure.
check the even length palindromes as well. Right now, you can handle this a bunch of different ways. The way I'm going to do it is setting the left pointer to I and setting the right pointer to I plus 1. So again, we're basically copy and pasting the code that we just wrote above. Maybe we could write a function to do this, but I'm too lazy to do that. So while it's a palindrome again, we'll check that the length is, we'll check that it's the longest palindrome that we've seen so far, basically. If it is, we update our result. And again, we can expand our pointers outward. And at the end, all we have to do is return our result. So I kind of made it look easy with the code, but don't let it fool you. It took me a while to write this before I started recording this. There's a lot of edge cases that can be kind of annoying.
Okay, so fair enough.
The if statement, checking that it's the longest palindrome inside of the while loop helped, I think, if you put this outside the while.
Okay, but this isn't the dynamic programming method. This is just a two-pointers method. Sure. And there's an even better method, which is using dynamic programming. So the two, oh wait, no, okay, so dynamic programming is the second best method, maybe. But this is the two pointers method that Leetcode was talking about. Sure. But the dynamic programming method, let's have a look. N squared space complexity, time complexity n squared. Whew. Manacher's algorithm uses O of n, space and time complexity. Let me think. Okay. Sure. That's very interesting. And then there's Manacher's algorithm. In O of n. Manacher's algorithm. Okay. Algorithms for competitive programming. I see. I'm gonna just get a drink. Here's what I'm going to do. I'm going to understand Manacher's algorithm after I've understood both two-pointers and dynamic programming. I mean, arguably I already understood two-pointers, but I want to solve it using two-pointers and then solve it using dynamic programming and then solve it using Manacher's algorithm. That's the plan for this question today. So let me understand here the dynamic programming approach. It's a 2D array. It's false times n. Sure. For I in range of the last letter, so you just go in reverse order. And for j in range I to n means still of n squared, right? Because I is 1. I could be 3. Right, so it could also be n minus 1. So n minus 1 to n is just n minus 1. They are equal. And this j minus I is less than or equal to 2. Or the dp of I plus 1 j minus 1. How the fuck does this dp work? G'day Nahi. How's it going, mate? How's it going? God damn it. dpij is true. I plus 1 j minus 1. How the fuck does that work? How do you think about that? Like, yeah, what, they're equal? Okay, it's a dynamic programming of that combination. Maybe. So from how do I even think about this dynamic programming still? Shit. It's not a very good problem for dynamic programming, is it? Man. Can't think of it. All right. Hmm. (1D) dynamic programming is all in time and all in space. No, I don't have an one. If anyone has one, please let us know. Yeah, I mean, yeah, that makes sense. What's been the most useful math you've learned in uni? I'm trying to see what I should learn after Calc 1. That's a good question. I've learnt about, like, there's only a handful of math subjects that I've taken so far. You know, I did Calc 1, I did Calc 2, I did vector calculus, I did real analysis, I did part of group theory and linear algebra, but I didn't do that. But I did do linear algebra. Okay, so those are the 5 subjects that I did. Linear algebra, vector calculus, Calc 1, Calc 2, and real analysis. I don't know if most of them were that useful, except for general knowledge. They might be like useful in terms of general knowledge, but I don't think they're really that useful in terms of the programming that I've done. If anything, arguably the most useful one was the most theoretical one, which was real analysis. Because you're talking about real analysis, you know, when you're learning real analysis, you're learning about sets and learning about what, you know, a set is fundamentally is helpful for when you create functions or think about functions when you're creating functions. It's like, you know, the set in math is the ideal for all the other sets that you create. Say like in Python, a Python set, a set of whatever. Knowing what a set is in math can inform you about how to use a set in Python. That's one way to think about it. But that's just almost like a very small example. So I mean, it goes to show like how useful it really is for me personally. But maybe, you know, if I go into theory more, if I go into computer science more, you would need to know a lot about like the real analysis side of things. And that also includes like predicates. So if you don't know what predicates are now, or if you do, cool, that's good. But predicates and prepositions, I think, prepositions, maybe. I think those are the words. I think you'll learn about, if you're learning about computer science, not necessarily software engineering, like those terminologies, those predicates, those, yeah, those terms are useful. That's all I can say to that. Okay, but why does this palindrome work? So why does this DP work? How does this DP work? For I in range, wait. Okay, single characters in palindromes are all true. And the longest palindrome is SI. Where does S come from? Our string. So you're just saying you're just taking the the first number or letter. Yeah, well the last one, yeah, that's fine. All right. Check substring of length 2 and greater. Size of window to check. End of the window. Update what the longest palindrome is. DP I plus 1 and J minus 1. This evaluates the truth if the substring between I and J is a palindrome. Do I agree? Oh, I'm like lagging a bit. I can kind of see myself chittering. Okay, yeah, I really have a skewed view of programming and CS in general. I thought all that high-level math was used. Nah, it's really not. It's easier than you think. At least to me. At least to me. You don't need that much calculus. Just know the area under the graph, probably. Okay. This is still very interesting. All right, here's what I'll do. I'll copy this solution though from Enrique. Gives a good explanation. Oh, that sucks. Maybe I'll just do a copy and paste. Okay. Like, do I fully understand it still? So it's create a 2D array where it is n by n, where n is the length of the given string. Then for the first row, the window size is 1. And for the first row, the window size is 1. Then, and subsequent rows increment the window size. Subsequent rows increment the window size. If ooh. Yeah, like what is the point? What about discrete math? I see it in a bunch of curriculums. Yeah, so discrete math is still, I guess, somewhat useful. I didn't do a discrete math subject. Did I? But I feel like it should be useful. Maybe, that's why, maybe none of the other maths really called to me. It could be that I missed out on doing discrete math. So, I wouldn't throw it out the window to do discrete math. Definitely do it if it's part of such curriculums. Okay, so the thought process is if nope. When the window increases, your DP problem, say you're at this one. How does this work? Let me sit. Hello, Georgeville. Okay, I'll stop yapping your ear off after this. Nah, man, that's alright. That's actually okay. It's all good. Which CS course, book, or learning resource did you find most useful? I guess there wasn't really one that stood out to me. I guess, okay, actually. Yeah, it doesn't have to be a textbook. It could be a full-on, really good learning resource. Let me think. Which ones have I used in the past? I guess the biggest one was one that was provided by uni, so I don't know how useful this is to you. But it was using Grok. That's where I learnt my Python first. And I learnt it pretty well there. That was like when I first was learning Python, and stuff, but I later relied more on documentation. And that's where I found, you know, learning to read documentation is really beneficial. And so I just stuck to reading documentation. So it's a variety of resources when it got to the documentation aspect. But for me, when I first started, it was the thing that got me invested was Grok learning, I think. Grok Academy. So my brother got me an account from here. And this was also in our teaching classes. So at uni, they also made us use Grok to learn about programming and to learn about Python, the language. Let me check if I have an account still here. See if I can get access. Let me also try logging in. So Grok. Okay, maybe I don't have Grok. Unless I used Google to sign in. Let me see. No, okay, so it's not this account. I want to find this. If I can. Sure, so maybe not. I feel like I would have had something. Jesus. The pings. Featured courses automatically. Browse all courses. Oh yeah, no, it is. It is definitely this. You see all these red, green diamonds? That means I finished them. So I did this when I first started my Python learning. And to be honest, maybe I'll download the certificate. Right, so this is what I did. There was also continue course. I'm not going to course. I'm a student. I'm in shit. I am in a student. Oh, I'm in grade 13 at. Not gonna bother. Okay. Oh man, this brings back memories. Actually, not bad. What other ones have I done? I don't know how else to see it. Information privacy and security, Express, HTML, CSS. I didn't do this one. You are in UX design. I mean, maybe that'd be pretty useful, eh? Damn, Grok is kind of... Is this just my account? Am I even... 1 year secondary student subscription. It's active from that's interesting. Yeah, 1 year tertiary student subscription. That makes sense. But this is not even 1 year. This is like 2 months. And this is active. And this is my invoice. Discounted 100%. And so this was sponsored by Grok Academy. Okay, so somehow if I just join back, it just gives you 1 for free. PayPal $30 for a year. Okay, introduction to programming. All right, these were what I did also. Oh, and you can see I halfway finished Intro to Programming 2. But I did Intro to Programming Original as well. So yeah, you can kind of see all of this stuff that I did. And this was back in 2020, 2021. Not bad. We're talking like 3 years. Kind of. Okay, I just downloaded the same thing twice. It's alright. But, yep, that's Grok. That's what I used there for a bit. Okay, that's it though. Let me check. Let me check my messages a second. So I'm reading a number of text messages. Yeah, Nahi. Oh yeah, what you say about the documentation, yeah. That's it, the documentation is just OP. Anyway. Damn, this is, I get pings on my watch, and maybe I can actually configure it to not ping me. Give me a sec. Notifications. Nope. What are the gestures? Double tap. Double tap is pretty sick. Alright, I'm just playing around now. Alright. go back to where it matters. Okay, I think if I go to sound and haptics, maybe. Nope. Probably just need to go to the app itself. Oh, wait, there is no app for this. Let me think. Well, I'll do it later. Fuck it. Okay. Them texts are done. Okay. God damn it. I so want to turn this off. Wait, give me a sec. Pause the camera, pause the screen. Okay, I got rid of the Discord notifications on my wrist now. Okay, however, what does this mean? Okay, check substrings of length 2 and greater. For lengths of range 2 n plus 1, the size of the window could be at most n, could be at most 2 to n. For I in range n minus length plus 1. Why length? Iteration limit for the window, because you can only have that much in the window. Okay. J equals, so sure, so J equals 0 plus length minus 1. Sure, that's the end of the window. If I equals J, is greater than length of the longest palindrome, update the longest palindrome. Okay. Sure. Longest palindromic substring dynamic programming. Geeks for geeks. Okay, given a string, find the longest substring, which is a palindrome. Given the string, the output is this. Geeks, output is Z. Tabulation. Yeah, and so this method, this approach is the one that's explained here. Should be the two pointers approach. The brute force is this. Is it? No. Given a dynamic programming. Manachers. It's definitely a lot. Ooh, this is a string of text. Yo, how is there parts 3 and 4s? There are so many parts to this. I don't think this is really that valuable then. If it's not going to summarize it in like this, I don't see. Yeah, so this is going to be interesting for me to learn. Right, this is interesting. This isn't. This is. Dang. I can see how this is dynamic programming. Tabulation. But what other method is there? And you're calling this brute force. Okay, we'll understand this though. And then we'll look at that. Okay. Hello. Rawat. Hello, Rawat. I'm just going to call you Rawat. I'm about to like butcher it otherwise again. GG. Every time, man. I'm just calling you Rawat. It's actually so funny. Okay, using dynamic programming. The main idea behind this approach is that if we know the status, palindrome or not, of the substring ranging ij, we can find the status of the substring ranging I-1, j plus 1. By only matching the character str I-1 and str j plus 1. Fair enough. If the substring from I to j is not a palindrome, then the substring from I-1 to j plus 1 will also not be a palindrome. Otherwise, it will be a palindrome only if this is the same. Based on this fact, we can create a 2D table which stores status of substring, string ij, and check for substrings with length from 1 to n. For each length, find all substrings starting from each character I and find it in a palindrome or not using the above idea. The longest length for which a palindrome formed will be the required answer. Follow the below illustration for a better understanding. Consider the string geeks below is the structure of the table formed. And from this we can see that the longest substring is 2. Geeks. Geeks. E. G&G, E. This is DPII. It is DPII. Give me a sec. Raw what? Alright, easy. I'll say like raw what. Raw what. Raw what. Raw what G. Raw what G. I think, yeah, no, that's definitely better. That's definitely better. Raw what G. Raw what G. Okay. So I can imagine, right, this aspect of it now, where it's on the diagonal, all ones. So this is the Boolean table, n by n, that's filled in a bottom-up manner. Iterate for all possible lengths from 1 to n. Iterate for all possible lengths. Each length, iterate from I equals 0 to n. Find the end of the substring j. The value of table ij is true if the substring is palindrome, otherwise false. Yikes. I plus length minus 1, yeah, that would be it. The value of the table is true. The substring is a palindrome, otherwise false. Check the value of what to calculate. No, you're meant to calculate the other way around, right? Maybe. If the value is true and string I is the same as string j, then we make table ij true. We have to fill the table initially by substrings of length 1 and length 2. Update the longest palindrome accordingly whenever a new palindrome of greater length is found. So that window gets shifted. For all possible lengths. Okay, I think I have it. I have the idea. All right, so we're going to try it. Let me just formalize it in a few sentences first. So dynamic programming method is slightly worse. Time and space. Create a 2D array where n by n, where n is the length of the given string. Then every dpij is whether the palindrome, whether it is a palindrome or not. So if it's not a palindrome, you do nothing. If it is a palindrome, but what is the condition at which you say that it is good? Okay. I'll think about it. Vishal, thanks for answering that for me. Yeah, even when I was before streaming, yeah, I did speak to myself about it. Probably not as much as now though, but definitely I did like to speak out loud. You know, people call me crazy. Nah, they don't really, because people usually don't hear me speaking by myself usually. But yeah, speaking out loud is definitely, I think, good for me at least. So, okay, let's try the two different methods. However, how do you, like, how is this bottomed, how is this bottom upped at all? I'm looking at this implementation and thinking, how does that bottom up? Let's go back. That window. That's false. I plus 1, j minus 1. That is one less. Right, these are all positions, so to speak. So that is considered one less. Okay, I see. Yeah. And that should be true. If that's true and this is true, then this is true. And if the length is greater than the current length, then you know to update the longest palindrome. Okay, I got it. I get it. I get the DP idea now. I can implement this. So I see Vishal, yeah. Epic. I don't know if you watched Death Note, but that reminded me of this meme about Light yelling, talking to himself in his room, and his family is just quietly eating dinner. Yeah. I don't know. I've heard of Light. I've wanted to watch Death Note at one point. I haven't yet. But fair enough. All right, here's what we're gonna do, right? So now that we've understood the problem, finally, we're gonna redo this in two different ways. All right, first I'm gonna do the way of 2 pointers, and then I'm gonna do the way of dynamic programming. Okay, so the 2 pointers way, we're gonna do it right now. So the 2 pointers way is to start from the middle and go outward. So for character and string, you start from the middle. I guess you can say for character in range len string. Maybe this is just I. And I don't know about where to specify the left and right pointers yet, but yeah, left, right is equal to I. Left is going to be decremented by 1, and right is going to be incremented by 1. And if so, while L, no. While 0 is less than L, zero is less than L. When L reaches 0, it's going to be not the case. Less than equal to L. And right is less than equal to S, ln of S minus 1. If I'm using ln of S, it doesn't matter. And S of L is equal to S of R. The result len is equal to R minus L plus 1. Res is equal to S of L to R plus 1. Res is equal to nothing originally. Res len is equal to 0. So this is the case where it's odd. 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 Or even. Odd. Even. I think that's right so far, for the odds at least. Let me think. This is an odd numbered. Yes, it is. Let me see the odd numbered. Oh, we never returned the result. Ooh. Output is D only. Wait, why? Yeah, okay, yeah, it's just at the very end. So if res len is greater than, sorry, is less than R minus L plus 1, then this is where you update it. Alright, so this works. But the case where it's even, you have to be careful. Okay. Let me think. So this is only giving 3. Should be only giving, you have to add it here. And then you would have the same exact code. Yeah, all right. You just duplicate it. However, do I want to really just duplicate it like that? You know? Maybe we'll make it a function. Check palindrome. Given left and right. So then we'll go check palindrome LR. Sorry, II. Paste it here. Non-local res non-local res len. Odd palindromes, even palindromes. Okay. Even palindromes and odd palindromes use this same function. Vishal, thanks man. Is that a sign that you'll be leaving now? Because that's all right. I'll be here for a while. Okay. Thoughts on Mac M4? I'm upgrading from a HP laptop running Linux. I mean, I would. I'm actually thinking of getting one myself, because even for this Mac M1, I'm thinking it might be better to upgrade. But I'm not getting one yet because I'm going to be using one or using a pretty good Mac when I start working at Amazon. That'll be yeah, literally in less than 2 weeks. So I'm pretty set on just choosing a Mac M4 after that, when I've felt what a good laptop could be, and then I miss it from this laptop because this is an M1 MacBook and it's been a while. They give you a laptop? Yes, they do. but you can't keep it. Like after you're done with the job, you're not keeping it. Alright, just motivated me back on the grind. Thanks, David. See you later. Alright, peace, man. I'll continue trying to do this with a DP problem now. Alright, let's restart. Okay, DP. DP is going to equal to two-dimensional array where for something in range of n, and n is equal to len of s. Right, for every window for every window for I in range len of s or range of n. So you start from 0, or you could say maybe you just start from 1 all the way to n plus 1. So this is the length let me see, from 1 to n plus 1. That's your length. For I in range. It starts from 0. It starts from 0 to length. So right. So n minus length plus 1. Because if length is 2 and you have 3, then it's 1, 2. It's only 2 possible. 0 and 1. Right? So if length is 2, total length is 3. 3 minus 2 is 1 plus 1 is 2. For every length and for every iteration of that. You start from the smallest. So if length is equal to 1, okay, you can define what j is. J is the other end, which is I plus length minus 1. Let me think. Length is 2, 0, 1, 2, minus 1 gives you the j position. The dp of I, j is equal to true. Okay. Kua, hello Kua. Watching someone else work is peak procrastination. Oh man, that's alright. Just work with me now. Just you do work while I do work. Should be fine. You know what I'm saying? Okay, if this is equal to 1, then dpij is equal to true. And then you would continue. Wait. No, that's not where you're meant to continue. Okay. If elif length is equal to 2, only if S of I is equal to S of j. Else, so other lengths. If it's 0, length of 1 minus 1 is equal to 0. So 0, 0 is true. If you have 1 plus 1 minus 1 is 1, it's still just 1. So that would also be true continuously. Okay. If length is 3 or more, if Si is equal to Sj and dp of the previous is equal to true, then dp of ij is equal to true. Kwa, how long did you used to study before knowing a lot about programming? I don't know when, like, I don't say I know a lot about programming. But, you know, there's definitely not like a boundary exactly when you know and when you don't. Because it's all like you build up eventually, right? Incrementally. And I would say like my study habits have changed throughout that time. Like it's been pretty consistent even still. So like the length in which I study is still about the same. So yeah, I would say like, you know, it's not really changed how long I've been studying. And you can kind of see like throughout my previous streams how long that is. If dpij is true, and length result length is going to be 0 originally. Reslen, then res palindrome. The palindrome PDP of, so it's between I and j. So I can say si to j plus 1. I think that's it. Okay, I never return it, obviously. Okay, all right. So it kind of works. I think that's what causes me to procrastinate sometimes. You're always learning and growing, I feel like, because I started late, I'm always going to be behind. Well, that sounds like I've heard that in the past. Okay, Qua. So you know the person before you, actually Nahi, is literally just in this chat, right? He might be gone off to study now, but he also asked a similar problem about, you know, feeling like you're behind. And here's the thing. I made a video on it. Well, actually, it's just a clip of my talk with Nahi. Well, mainly it's just my rant. But it's a 4-minute watch if you want to watch that, to get an idea of the insights that I brought to that idea, okay, of feeling behind in life. So I recommend you watch that. It'd be immensely helpful. Like, just go off now and just watch it. And then come back to it. Come back to me and tell me what you think. It's, okay, wait, let me show you what the video is. It's like, it's called I Feel Behind in Life, I think. You just see it on my YouTube channel. It's taking forever to load YouTube. It's actually taking forever. It's loading. Yeah, so I feel so behind in life. Watch this one, if you're not already watching it now. Alright, I'll close it again. Let's see. Why is this the case? What's the problem here? Maybe I gotta print after every length? Maybe. Print DP. True. Okay. J plus 1. I minus 1, J plus 1. Or is it J minus 1, I plus 1? Is it which way? Doesn't matter. As long as you pick one. I think it is minus. It is. Okay, I did it. Do you need to master a language and DSA to Leetcode? You don't need to master. Okay, yeah, no, you don't need to master it. Just get rid of that mindset. All you need is some basic knowledge of a language of your choosing, preferably Python. if you're going to follow Leetcode 150. And then the DSA you will learn along the way. So don't even bother, understanding all the DSA before actually starting on any of the problems. Like for me, look, I'm learning about dynamic programming kind of before I've even learned it properly myself. And just doing Leetcode problems for it, and I also want to understand this new algorithm as well, which is Manacher's algorithm. And, I'm doing this while I'm learning Leetcode or Leetcode. So there's no need to master all the DSA or a language. You will learn it along the way. Same thing with the language itself, right? You'll learn the language along the way. I didn't even learn about the heap queue that exists in Python until I actually had to use it, right? You don't know what you're going to be looking for when learning a language. If your sole purpose is to be good at Leetcode in the end, unless you do Leetcode problems, right? So don't focus too much, don't hone too much on the theory. All right, and just do some practice and learn it that way, through practice. Cool, so we solved that now using DP. That is much better. That is much better. Okay, I'm gonna put this as my solution to Alacrity. Exits, clear, CD, not Siri. Leetcode and Vim. So this problem is what? Longest palindromic substring, just number 5. Okay. Awesome. Love the DP. Where are you saving this to? I'm saving this to my own Leetcode repository right now. But if you're talking about like locally, this is saved, just to the local Git repo. But I'm using Alacrity as my terminal. I'm using nvim to copy and paste stuff into here and just doing normal git commands to git commit. Solved using 2 pointers and DP. This solution is in DP, or I should say dynamic programming. And these 2 solutions, both 2 pointers and dynamic programming, have only been solved from looking at the solutions provided by Leetcode and by Geeks for Geeks. There is also Manacher's algorithm to look into this problem further, which I have yet to do. All right, done. Git push is taking a while though. Okay. And I can understand Manacher's algorithm, but I should copy and paste this page because this is where I learned it. Actually, is it this page? No, it's this page. It's actually slow. Mohit, what is the schedule of development? Yeah, so it's just if you look in the description, there's a link to the actual open source implementation. So this is what I'm building just on the side for fun. Just doing it, building it. It's about scheduling. So my thinking is you can schedule tasks in a way that is automated. So, you know, maybe at a click of a button, you can automatically schedule your tasks and see it all as a backlog throughout the week, right? And then you kind of know how you have a gauge of how well you can accomplish tasks. That's the idea, you know. It's just hard to implement, and I want to do it well, you know. But doing it well is one thing. It's just going to take some time. And yeah, it's also a learning experience for me because I'm learning quite a lot through it as well. That's about it. And it's all going to be free and open source. Okay. I can copy this. Close that. Geeks for geeks. Okay. Nope. Give me a sec, guys. Okay. Gotta quit Mackie every day. Okay. Quit Mackie. Okay. 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 Oh, hello, welcome back, Kwa. Kept replaying the video. Damn. Oh, I'm glad it changed your perspective of things. Oh, and apologies for the frame rate drops. My laptop can't handle it. But okay, that's really good. That's really good to hear. Yeah, it's awesome to hear. You know, that's what kind of fuels me to make these videos, or like, you know, stream also. So appreciate you telling me that. It means a lot. All right. It truly does. Give me a sec now. Something's changing. Yeah, Kwa. You're definitely not alone. Definitely. And now you see me blurred as a person right now. Trying to figure out why. Fixing summon. Fixing something with my phone. Yep. And by the way, the phone is literally what's streaming my video. So okay. Monkeys. 13. Okay. All right. God damn it. We're log in again with another account. All right. I gotta figure that out later. I'll figure that out later. Let me put this back on streaming my video. I don't know how to do that actually. It might just be that I have to quickly BRB. Gotta turn off restart OBS. Give me like 5 seconds. Yeah. So I think I'm still blurred out. I think things aren't working for some reason. Oh no. So there's no camera, but I think you can see my mouse. I think I know why. I think the reason is because I just changed my password a minute ago on my Apple account. Could be causing it. Don't know how to fix that actually. Wait. Is there a way? Surely. Oh wow. Everything's just slow. I need a better PC. I need a better PC. Soon. Wait, let me close some tabs as well. For real. On second thought, you'll stay with your HP. Yeah. Valid. Nah, I think even M4 is like 4 times better than this. My laptop. And also, given that I have 8 gigs of RAM, this is even worse. If you had more gigs of RAM, you know, it would be reasonable. I'd like to quit this. I don't know how. Settings. Quit. How can I just quit? Can I just go like this? Eight gigs, yes. Yep, I chose 8 gigs. What can I say? It was a bad choice. I won't lie. But you'd be surprised how much you can fit into 8 gigs for real, actually. Actually pretty tight, but borderline unusable. Like right now. Also because of the heat, it's even worse. So it's being throttled. Manacher. Okay, that was way worse. Memory, way worse as well. So you guys, most people just do it in terms of a 2-pointers problem, and then they just leave it at that, don't even bother with a DP. Fair enough. You're getting your money's worth, for sure. You know how much this cost, like this specific laptop? It was literally the cost of the base model iPhone 13 flat, like the base model iPhone 13 was the cost of this MacBook M1 Air. Still curious, like why is what's happening? Why isn't this working as I expected? Very interesting, to say the least. That's alright, I'll leave it off. It's also heating my phone quite a bit also. Keep my phone to the side. Drink some water. Let's understand algorithms for competitive programming. In this case, it is Manacher's algorithm. Okay. Turn it to dark mode. Not bad. Do I care? Yes, I do. I'll keep it dark mode. Alright, and then I should put a previous solution just in case I lose it. And then same for this, I'll put it here as well. Sorry. Copy it. Paste. Okay. Nice. Arguably, I could slim this down a bit. If length is equal to 1 or length is equal to 2, maybe Sij, then DP true. I mean, you can think about it this way. If dpij is not equal to true, I mean is equal to false, you would just continue, right? And then you wouldn't do any of this. So then you wouldn't need this, and bring that back. Sorry. This is not what I wanted. Si is equal to Sj if it does not equal to, then you would do that. And then maybe an elif. I'm convinced to keep what I already had, but this makes it simpler to an extent. It's an accepted solution, but I don't know. It's not very easy to tell what's going on. I think it's easier to tell what's going on with what I had originally. Maybe. Over time, things may change. I may misunderstand. I may make this harder for myself. Okay. That's fine. Okay. Yeah, I'm just leaving this as is. And then understanding Manacher's algorithm. Let me drink some water and I'll be right back. Okay. Now I learned a lot about dynamic programming there. Let me see. Oh damn. Sorry, my whatchamacallit laptop is hot. Look, I want to still see how to get my phone to work here. Thing is, I gotta check. What's the name? What is how to? What is this? Continuity camera. You know, it's probably worth just a restart. So it's not even worth searching up too closely. Keep the way it is. Content-wise, let's have a look. So I'm going to change the title of this to Learning about Dynamic Programming, Leetcode plus the Leetcode problem, DP problem, plus learning about Manacher's algorithm. Okay, we're gonna learn about Manacher's algorithm. Okay. It's 5 p.m. It's 5 p.m. I gotta figure out how to also turn off the ping on my watch for every hour. I think that's a bit annoying. Give me a second. I mean, it's kind of notifications. Text tone, email, default alerts, crown haptics. No. Okay. All right. Let's learn about Manacher's algorithm. All right. And Manacher's algorithm basically deals with longest substring longest palindromic substring. Okay, so the statement is, given a string S with a length n, find all pairs ij such that the substring Sij is a palindrome. String T is a palindrome when T is equal to T reverse is a reverse string of T. More precise statement, in the worst case, string might have up to O of n squared palindromic substrings, and at the first glance it seems that there is no linear algorithm for this problem. But the information about the palindromes can be kept in a compact way. For each position I, we will find the number of non-empty palindromes centered at this position. Really? But for the information about the palindromes can be kept in a compact way, This is pretty good though. Yo. No, I've never done these. I was gonna say, are these marked because I've done them? No. I've never done those. Okay. All right. Palindromes with common center for a contiguous chain. That is, we have a palindrome of length L, synonym I. Palindromes of length L minus 2, L minus 4, and so on, synonym I. Therefore, we can collect information about all palindromic substrings in this way. Palindromes of odd and even lengths are accounted for separately. For the palindromes of even length, we assume they're centered at the position I of their two central characters. For instance, ABABA-BC has three palindromes with odd lengths and centers. It strings this. This is a surprising fact that there is an algorithm that's simple enough that calculates this palindrominy. So in general, the problem has many solutions, string hashing. Okay. Inconstant in time and memory complexity. Manacher. EER tree. That's so funny. Tree. Ear 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 tree. Sorry, I just had to make sure that's right. Ear tree. Trivial algorithm, so to avoid ambiguities in the further description, we denote what trivial algorithm is. Okay, and then that's Manacher's algorithm. Complexity of Manacher's algorithm and implementation of Manacher's algorithm. It's possible to implement Manacher's for odd and even lengths separately. The implementation of the version for even length is often deemed more difficult, as it's less natural and easily leads to off-by-one errors. To mitigate this, it is possible to reduce the whole problem to the case where we only deal with the palindromes of odd length. To this, we can add additional hashes between each letter. Whoa! That is interesting. That is interesting. Oops, sorry. Okay, well, I ain't implementing all that. Definitely cool to know. Cool to know. We'll look at the solution though. This is cooked. Alright, yeah, all of it's putting hashes in between. Manacher P. Max of VI for IV and enumerate P. Ooh. What in the world? No, what in the world? Alright, well, the question, the thing becomes then, understanding Manacher's algorithm is something I vaguely understand to an extent, but I won't look too deeply into, because I don't think it's really required. However, right, so we did that problem. Do we want to do one more? That's the real question. Say to catch up from yesterday's miss, we could do a problem right now. Say, yeah, we definitely could. And if I do it, I might just have to rearrange a few things. Okay. Yep. So we're going to do one more Leetcode problem and then we're going to call it a day. All right. So that Leetcode problem we're going to do is a good question. What question do we want to do? Again, we can do a 1D dynamic programming problem again. I'd be fine with doing it. Or do we want to also have a little play around with greedy? Maybe not. Maybe not. There are only a limited number of questions left for me in reality. Because once I finish, how many is that? 75, 25, 22. There's 22 problems there, which means we get up to 116, there'd be another 40 problems in Leetcode 150, which I can do. All right. Yeah. Not bad. Not bad. But a lot of problems. Okay, there's a lot more problems in 2D dynamic programming for the Leetcode 150, which I won't be mad to do more of, you know, actually. Those are actually pretty useful. Okay. Not bad. Leetcode all. How's the Leetcode all going? Okay. Sure. Okay, so we're going to try another dynamic programming problem. Out of the blind 75. Okay, palindromic substrings. We're going to do another palindromic substrings problem. Given a string S, return the number of substrings within S that are palindromes. A palindrome is a string that reads the same forward and backward. Palindromic substrings. Explanation A, B, and C. Input S, A, explanation A. Note that different substrings are counted as different palindromes even if the string contents are the same. I think I know like how to do this. This seems to me the same problem that I know to solve. This is exactly the problem that I just did. Okay, if that's the case, maybe I don't do it. Decode ways. No, maybe I will do it. I will do it. Alright, we'll just do it. I know how to solve this one. Alright, let's just do it now. Except I want to be able to share my screen with it, okay? So give me a moment. I want to see if we can get screen share going. Okay, I'm back. We got it. Working, it's just working now, so epic. Alright, this problem, once it's solved, I am done for the day. Gotta focus on some other smaller tasks later on. Okay. So, maybe I'll make it brighter right now. Do I want to do this standing or sitting? Maybe I'll do this standing. Alright, I'll do this standing. Standing up. I'm standing up right now. Do some good work. Alright, let's do some good DP work. This will be good. DP. I'm gonna say new tab. So, ooh, here we go. Okay, palindromic substring. Ooh, actually, even in this one, I didn't finish writing stuff. God damn it. The lag is surreal. Is unreal. Dynamic programming, technically bottom-up dynamic programming. Technically 2 pointers. Brute force, did I ever write brute force? No. Why not brute force? Brute force. Yeah, that's it. And the problem that we did before was longest palindromic substring. Okay. Nice. All right, now we can get rid of this one. And we can go to this one. So this problem should be similar to longest palindromic substring. Okay. I can close longest palindromic substring. So find the number of palindromes, that number of subpalindromes that reads forward and backward. Right? Yeah. Subpalindromes could include the whole string itself. So if you have AAA, then it could include AAA. Okay. Just gotta fix my pant. Okay. Let's go. So DP is, okay, not loading. Let me refresh. Let me drink Yakult. Got the Yakult right here. Let's drink the Yakult. The brain drink. It's not really the brain drink. It's more like fix your bad breath drink. Kind of want to drink some water now. Be right back. Need to drink some water now. Let's go. dp is equal to false times n for underscore in range of n, where n is equal to the len of s, and the result is equal to 0 for length in range of 1 to n plus 1 for I in range of 0 to len n minus length plus 1. J is equal to I plus length minus 1. You have I and j now. dp of I, j if s of I is equal to s of j, then continue if it's not, right? If it's not equal, then you wouldn't do anything to it. But if it is equal, let's have a check if the other parts are as well. If length is equal to 1, dp I j is equal to true, and res plus is 1. If length is equal to 2, alright, length is equal to 1, technically if it's equal to 1 or 2, then that's fine. Else, if it's 3 or 4 or 5, if dp of I and j, now this is I plus 1, and this is j minus 1. If this is equal to true, then dp I j is equal to true, and res plus equals 1. And then return res. Am I convinced? That is working. So maybe what we need is elif this, but di end of word, di end. Oh, maybe we just do this. Or dp I plus 1 j minus 1 is equal to true. Right. If it's length less than equal to 2, less than equal to 2, or this is the same thing. Okay. Yippee! Easy peasy. That was much easier, I feel. GG. YG. Oh, oh. Palindromic substring. Okay. Alright. Okay. Solution. Brute force. Dynamic programming. 2 pointers. And 2 pointers optimal. And then Manacher's algorithm again. Shit. Ah, shit. Should I understand Manacher's algorithm? Should I understand the 2 pointers optimal approach? Count pala? Basically the same thing. It's basically the same thing. Except I did it with, yeah, 2 pointers. I mean dynamic programming. Yeah. In fact, it is very similar. I am now just to practice that solution. In 10 minutes, no more. Okay, well, let's have a look at the video solution anyway. We'll understand it more, but it also means you can put down some tags. Bottom-up dynamic programming, 2 pointers, brute force, yeah, that's it. That's all it is. Okay, let's have a look at the solution. Palindromic substrings. And we'll close this solution. No, we'll go to the description and we'll go to add this to Alacrity. Git add, git commit. Okay. Now here, I was just about to give that same solution. As in you've done this problem as well just now. Oh yeah. Oh yeah. Oh yeah. Let's go. Palindromic substrings. Oh. God damn it. It's so slow. Hell nah. No. Well, that's alright. We're gonna watch this. Make sure we understand every part of this.
Hey everyone, welcome back, and let's write some more neat code today. So today let's solve palindromic substrings. And this is another problem from the Leetcode Blind 75 list, a list of 75 very good Leetcode problems to solve. And this time we will be doing palindromic substrings down here. And so we are getting one step closer to filling out this entire list. And this problem, palindromic substrings, is actually really similar to another problem I've solved, longest palindromic substring. So if you would like to, I'd recommend watching this video as well, longest palindromic substring. I will probably link it in the description below. So simply, we are given a string S and we just want to return the total number of palindromic substrings contained in the string S. And as you may know, a palindromic substring is basically a string that can be read backwards, and it's the same string. So, you know, A, if you read it backwards, it's the exact same string, right? A, B, A. You know, this is the same string reversed, you know, because the first character is the same as the last character, and then in the middle we're just left with one character, and you know, basically that kind of pushes us towards a base case. So as you may know, there's two types of palindromic substrings: strings of odd length, right? So for example, just a single letter A, that's a palindrome, right? It's the same backwards. If we add a B to the beginning and a B to the end, it's still a palindrome because now we expanded it outwards with the exact same character. Similarly, we can do the same thing with even length substrings as well. If we have two A's in the middle, then of course this is a palindrome. And then if we continue to expand outwards, we add a B at the beginning and we add a B at the end, it's continuously going to be a palindrome because these characters are also matching. Now if we, instead of adding a B, we added a C at the end, the inside
Well, I think I'm still back. I think I'm back. Okay, I think we're fine. Restart it again. You know what I mean? Alright, let's continue.
we are given a string A, B, C. Now, of course, we have three
Perhaps.
palindromes because each character by itself
Perhaps
is
it
a
exploded.
substring, of course, and each of those by themselves is a palindrome as well. So that's three. Now, is any other substring, for example, AB, that's not a palindrome. BC, that's not a palindrome. ABC, that's also not a palindrome. That's basically all the substrings available to us. So we only find three, so we're going to return three. So let's understand how we can do the brute force solution, which is actually big O of n cubed.
N cubed.
We can actually optimize it a little bit, understanding how even and odd palindromes work, and then we can get a big O of n squared time complexity solution.
Big O of n
let's say
squared.
we're given a string that looks like this. If we just start brute forcing it, we want to go through every single substring, right? So every single substring starting at this first position would be something like this, right? There's these substrings, right? Then we'd want to go through every single substring starting at this position, which would look something like this, right? In total, there's going to be n squared substrings, right? And for each substring, for example, you know,
Yeah, we're back.
we need to determine if it's a palindrome or not. And we know, you know, that's not a difficult algorithm to write. We could have two pointers, one at the beginning, one at the end. We basically keep comparing the characters and making sure that they're the same, right? So, and for a substring like this, we'd also have two pointers, right? Compare that, okay, these two characters are the same. So then we can move pointers here And then we see,
Indeed.
okay, this character is also the same. And then, we go through every character. So we determine, yes, that's a palindrome. Then we can increment our count of palindromes, right? We'll call that our result variable. So then we'll add 1 to it, right? Because that's ultimately what we're trying to return, the number of palindromic substrings inside of this string S. And clearly finding and determining that a string is a palindrome is also big O of n. So since there are n squared substrings in the entire string S, and for each of those substrings, we have to determine that it's a palindrome, we're going to multiply it by n. So this is going to give us an n cubed time complexity. Now, we can improve this, and it's going to require us to solve this problem in a different order. What we're instead going to do is we're going to go through every single position in this, right? Instead of finding for this position all the substrings that start at this position, we're going to find all the substrings that this position is the middle of. So instead of, just going to the right, we're actually going to expand in both directions. We're going to go through all substrings where this position is the middle position. Now, clearly, this string...
Oh, I paused it.
itself is one string, right? And this is a palindrome. So we're going to have our left and right pointer just initially at this position. We're going to see that, okay, both of these characters are the same, right? So then we can take our result, add 1 to it, right? So we did find one palindromic substring, and then we're going to try to expand outward, right? Our left pointer is going to go here. Our right pointer is going to go here. Clearly we go out of bounds though to the left, right? So basically what we're saying is there's only one substring where this is the middle position of. And then we're going to do the same thing for here. So from this position, we want all substrings where this is the middle of. So we're going to have our left and right pointer initially here. Yes, this character, our left and right pointer point at the same character. So we found one palindromic substring, just the single character itself. Then we are going to take our left and right pointers and then shift them. So left is going to go over here. Right is going to go over here, right? So now let's compare left character and right character.
I think this is all like the same anyway. We get it.
Middle portion is a palindrome, right? Now we only have to compare the left and right characters, the new left and right characters, if they are equal, right? Which they are, A equals A, right? So therefore, we found one additional palindrome. This palindrome of length 3.
Yeah, his coded solution is literally the same.
This character is still the middle.
Doesn't matter.
Once that is done, we can go ahead and return our result. Now, as you can see, this solution works. That's the entire thing. It's very efficient, but maybe your interviewer will want you to, this is copy and paste, and sometimes they don't like copy and paste. We can basically take these two and condense them down into a single function. So I'm just going to do that, even though I'm sure you could probably figure out how to do it. In this case, it's not too bad. So I'm going to make a function called count palindromes, and we'll pass into this
count pally
and right, and replace it with I plus 1. So then we can get rid of these two lines. And up above, do the same thing. So replace left and right with both I, and then get rid of this line. So this is a pretty version of this function. So with this...
Yeah, right. I mean, look, that's fine. Dynamic programming, like this isn't dynamic programming. Again, I've said all throughout today. But that's good. That's good regardless. Okay, I think we're going to call it a day anyway. I think I'm going to chill a bit. I'm going to then have to organize some stuff before I get to Sydney. Yeah. So there's a few things that I got to do which are kind of like more personal, but misc stuff in the sense that it's miscellaneous. So unrelated to the stream, but we'll be back tomorrow to do more Leetcode problems. All right. Thank you, Nahi. I'll see you later, man. Have fun and don't overwork yourself. Peace.